Near the end of the 19th century, J. Thomson conducted investigations into the nature of matter. These seminal investigations led Thomson to discover a charged particle common to every substance tested. A cathode ray tube consists of a glass apparatus that contains a partial vacuum. Electricity is passed through the tube via two electrodes, a negatively charged cathode and a positively charged anode. The electric current generates an energetic beam that travels the length of the tube, starting from the cathode, passing through the hole in the ring-shaped anode, and striking the far end of the tube. The invisible beam, i.e. the cathode ray, is revealed to human eyes by including a fluorescent coating in the tube. We will show the beam in the animations for clarity. A cathode ray is perturbed by an external magnetic field. This phenomenon established that the cathode ray contains mass. Try it yourself. Move the magnets and observe the effect upon the cathode ray. Electrons are drawn to the positive plate. Electrons are deflected away from the negative plate. The path of the cathode ray is also affected by an external electric field. Thomson used that phenomenon to determine that a cathode ray is charged. Try it yourself. Turn the external electric field on and off and observe the effect upon the cathode ray. By studying the magnitude of deflections of cathode rays and different strengths of electric and magnetic fields, Thomson determined the mass-to-charge ratio of the beam particles. Try it yourself. Use the external electrical field and the magnets to counteract each other, giving an unperturbed cathode ray. Thomson found the mass-to-charge ratio of the beam particles to be about 2,000 times smaller than that observed for hydrogen ions. This result suggested that the particles were either extremely highly charged or were much lighter than the lightest element, hydrogen. The cathode ray tube experiments demonstrated the presence of both mass and charge in the cathode ray. Later experiments conducted by Millikan demonstrated that the beam particles are very lightweight rather than highly charged. The lightweight negatively charged particles are electrons. Thomson's research established the existence of electrons, determined the mass-to-charge ratio of an electron, and demonstrated that atoms are made up of subatomic particles.